Hey y'all, welcome back. Tonight's homework's all about using the properties of logarithms that we learned in class. This first section is just asking us to use the change of base formula to rewrite these logarithms using the base that they're asking for. So this one's saying log base 5 of 16 and is asking us to write it using base 7. So the way you do that is you create a fraction, and the fraction on top is going to be log of 16 divided by log of 5. So you put the original argument up top, and you put the base in parentheses on the bottom. Now this is saying use base 7. I just want to show you kind of the process of like where these numbers go if you're trying to rewrite this using just like any other base. And then you just put the given base here. This could be anything, and it'll still be true. So you don't have to think too much about it. You just throw in the base that you want. In this case, base 7. And so this is what our answer is going to look like. So notice now we're expressing the value of this using base 7. And you could test this in the calculator to see that these two are the same, and they definitely are. So number 2 is asking us to use the common log. So remember that the common log is referring to base 10, okay? And when you write a common log with base 10, you just don't put anything here. So don't put 10 here, you just put nothing, okay? If there's no base written there, then it's just assumed to be 10. So other than that, you're going to put the argument in the base, where they go here. If I can make this work. So we got log 47 over log 4. So these are both in base 10. Looks like that 0 didn't come up there. Yeah, so you don't write anything here when it's base 10. The natural log is that ln notation that you see over in number 4. So if we want to express this using the natural log, we do kind of the same thing here. So let me just copy this. It's just that instead of log of whatever base, we're going to just do natural log. And just as a little reminder, the natural log is a logarithm. It's just base Euler's number. So this natural log is saying that the base is e. Euler's number there. Okay, so up top we're going to put 14, and on the bottom we'll put 3. Finally, we want to express the natural log of x using base 2. Okay, so same kind of idea as the rest of these. You kind of see that there's a lot of repetition going on here. We're going to have log base 2. I'll throw in the base 2 in just a minute. And then so what goes on top is the x, and then you have to think, okay, well, what's the base here? Because it's not actually written. And so you have to know that the natural log is base e. So we'll say log base 2 of e. And I do need to put the 2 in there. So let's squeeze that in there. Click, there we go. So log base 2, and then down here we need log base 2 as well. So both of these logarithms are in terms of base 2. Number 5, we're going to express log of 11 using the natural log. Again, we're going to do something very similar to what we've got over here in number 2. Same base. So, oh wait, no, using the natural log. So I take that back. The natural log is the ln one. So we actually, if I'm going to borrow one, I'm going to take this one up here. So the number that's going to go up top is going to be 11, and then you have to know that when you don't see a base written here, it's assumed to be 10. So going back up here, this is the common log we were talking about earlier. So yeah, so this would be natural log of 10.
All right, so number 6, we got express natural log of 33 using the common log. So the common log is going to be your log base 10. So we're going to have log base 10, which is, let's make this a little bigger here. Log base 10, you don't normally write the 10. This is our common log. So whenever you see a log with no base written, it's going to be assumed to be 10, and that's what the common log is referring to. So this would be log of 33 divided by the log of the base of this natural logarithm. The natural logarithm has a base that's Euler's number, so that's going to be e. And so here you go. This is going to be how you can evaluate logs with these different bases in using a scientific calculator, or really any calculator that has the log function but doesn't give you the ability to type in your own base. You're going to have to use this change of base formula if you want to use the calculator to evaluate. Now, most of them will have a natural log, so this one's maybe not the best choice. But like if you have log base 3 and your calculator doesn't have a base 3, you want to try to rewrite it using a common or natural log, depending on what your calculator has.
Down here, we're trying to expand the logarithms using some different or constant multiples of logarithms. So we're going to use the properties that you have in your notes. And if you want to kind of go back and review what those properties are, just take a look at the lecture video that I posted for this, this lesson. So here we've got log of a product. So anytime you have log of a product, meaning two things that are being multiplied, we can rewrite them and sort of split it apart using addition. So we're going to write this as log base 5 of 25 plus log base 5 of x. Now we can simplify this because this one over here is going to be one that we can simplify pretty easily. So if you can simplify it, go ahead and do that. Here, 5 squared is 25. So instead of writing log base 5 of 25, we can write that a little bit more efficiently as just 2, which is obviously a little simpler to wrap your head around. So this is just going to be 2 plus log base 5 of x. For number 8, we've got the natural log of 4, okay, plus the natural log of x squared. So both of those two factors are being multiplied, so we can split this up like this. Now, it also says that we want a constant multiple of logarithms. So basically what that means is anytime we've got an exponent, we are going to rewrite it as a coefficient of the logarithm. So we're going to write this as natural log of 4 plus 2 times the natural log of x. Now, once I'm sort of done here, I want to look at my answer kind of like, I looked at number 7 and found that I could simplify this. But here, natural log of 4 is irrational, and there's not really much we can do here. So this is just going to be our answer. Now, both of these are using the product property, and down here we're going to use the quotient property. So anytime, like up here we saw we had products inside the parentheses, like 25 times x and 4 times x squared. But if we're dividing rather than multiplying, like we are in number 9 down here, instead of expanding them using addition, we're going to expand them using subtraction. So here we're going to say that this equals the log with base 10, so we don't need to write that, log of x minus log of 2, and then 10 to what power is 2? That's going to be irrational, so we can leave it like that. Not a lot of work going into this one. 10 is going to be similar. We're going to have the natural log of 3 minus the natural log of z cubed. However, we do want to expand it a little bit more. We want to take this exponent and write it right here. So this is going to be the natural log of 3 minus 3 times the natural log of z. And neither of those terms can be simplified any further, so that's going to be our answer for number 10. Let's keep going. Okay, number 11. Same kind of deal here, except we're going to have more than just one or two steps here, because we're going to have to use all the properties. We're going to have to use the quotient property, the product property right here, and then use the power property. So we'll just do one thing at a time. We'll start with the quotient property. We have log base 2 there we go, of 3y minus log base 2 of x to the 4th. So I'm going to take these individually. Let's take a look at the first logarithm and see if we can expand that a little further, which we can because we've got a product in here. So we can expand that out using addition. And write that as log base 2 of 3 plus log base 2 of y. And for this one, it seems to be mostly simplified, except we can still deal with this exponent like we did in number 10 and number 8. So here, we're going to rewrite that as 4 times log base 2 of x. And I'm looking through these, and I don't see anything that we can simplify past that, so this is going to be our final answer. Number 12, just like with number 11, we're going to use the quotient property first, so I get log of AB minus log of CD. And then I can use the power property, or the product property here. So log of A plus log of B, and you want to be careful in this next one though, because we're subtracting this entire logarithm. Almost think about this as like being inside of its own set of parentheses. And normally you wouldn't write those parentheses because it's just a single term, but I think it might help us to kind of see how it'll actually work out. Log of C plus log of D here. But the reason I put those parentheses here is really to emphasize that, hey, we're subtracting this entire expression. So we need to subtract each one of these. And so if we're really trying to simplify this, we got log A plus log B minus log C minus log D. Now, if you're getting lost in like the parenthesis thing, you know, maybe I'll just get rid of those just for now. Know that, you know, one kind of way you can get around that is to look at the fraction that you're trying to expand here. And any of the factors that are in the numerator are going to result in a positive logarithm, and any of the factors that are in the denominator will result in a negative logarithm. So just a little shortcut there that, you know, maybe that'll help you through some of the harder ones. Okay, so there we go. There's number 12. Let's move on to number 13. So here we are trying to condense into a single logarithm. So yeah, let's see what we got here. So we're trying to do what we did in the previous problems, this previous page, but go backwards. So we're trying to rewrite it as a single logarithm instead of trying to expand it. So yeah, let's do number 13. When we use the quotient property here, we're going to combine these into a single logarithm. So we'll have log base 8 of 54 divided by 2. And we can simplify a little bit, okay? 54 divided by 2 that's doable. So we'll have log base 8. What would that be? 27. And then 27 is not a power of 8. So we're just going to let that be our final answer here. For number 14, we are going to use the product property, and this one is going to take a little bit of extra work here because we need to multiply x, and maybe I'll use brackets here to make this easier to read, but x times x plus 3. So in order to multiply these expressions, I need to use the distributive property and multiply x by x, so that'll give me x squared, and then x by 3 to get 3x. So this will be the natural log of x squared plus 3x. And nothing to simplify there, so we're good, we're done. Number 15, we have 2 log x plus 4 log y. So what we can do is use the power property here and rewrite this as log of x squared plus log of y to the 4th. And then once we have that, now that, you know, our coefficients are both 1, we can use the product property and say that this is going to be log of, it's going to be x squared times y to the 4th. You don't really need that dot there, but I just want to really emphasize that we're multiplying. For number 16.
All right, number 16, I just changed this up a little bit. The way it was written was not really what I wanted it to be. So yeah, let's work it out with this new updated problem. First, we want to move these coefficients to be exponents using the power property. So I'm going to rewrite this as natural log of 5z squared, and we need to raise that whole thing to the second power. So just be careful with your exponent properties there. I'll simplify that on the next step. Minus the natural log of y to the 7th. Okay, I'm not going to combine these with the quotient property quite yet. I'm gonna square this out. So if I have 5z squared times itself, 5 times 5, or 5 squared is going to be 25. Z squared squared is going to be z to the 4th. So just be careful. Don't just square the z. You got to square the whole expression inside the parentheses. And then we've got natural log of y to the 7th. So now we can combine these using the quotient property. So I'm going to write this as the natural log of 25z to the 4th divided by y to the 7th. And that should be your answer for the new and improved number 16. Previously, it wasn't really a problem. It was way too hard. It was way harder than I wanted it to be. We had different bases, and I didn't really want to go there. So let's go back to the original video as we move on to number 17.
Number 17, we're going to start with the power property. This one looks a little bit more like what I will give you. So log base 8, let's get that base 8 in there, okay, so you know what? You know what I'm going to do here is I'm going to actually do this go a little slower here. So I'm not going to do anything with that first one. With the second one, I'm going to rewrite it using a power. So log base 8 of y squared, and then minus log base 8 of z cubed. So I just want to take care of those exponents first, and now I can start to combine. So you really can do all of this at once. Like what I was talking about earlier with the pluses and the minuses. Notice back here on number 12, where when we expanded them, the a and the b were both like positive logarithms, and the c and d ended up being negative logarithms. Just kind of the way that the subtraction works out here. So anytime you see one that's like broken down like this, you'll know, or you should know, that whatever logarithms are positive here will be in the numerator, and then the argument that has a negative logarithm will be in the denominator. But I'm going to take it step by step, but just know that like the end result here is going to be log base 8 of x times y squared all over z cubed. But I'll take it step by step just to kind of really spell it out here. So we get log base 8 of x times y squared. Again, you don't need the actual times here, the dot, but I'm going to leave it in there just to make it easier to read. And then, okay, so we've combined those, and now we can use the quotient property to get log base 8 of x times y squared divided by z cubed. So again, what I was trying to explain earlier is that, if you see these positive logarithms, then the argument is going to end up being in the numerator as a factor in the numerator. And then if you have like minus, and I'll show, like maybe on the next one, I'll take that shortcut. Any of the negative logarithms, the argument will end up in the denominator. So there we go for number 17. Number 18, like I said, I'm gonna try to work that out a little faster. So let's see, we've got log base 3 of x cubed minus 4 minus log base 3 of y to the 4th minus log base 3 of z to the 4th. So my final answer here should be log base 3 of, in the numerator, I'm going to have the x cubed, and then in the denominator, I'm going to have y to the 4th times z to the 4th. Okay, now if you want to see the algebra like in between, like if you really need to see those in between steps, one way to think about it is to put parentheses around this, and I think this just makes it more complicated, to be quite honest, but if you just really want to see how that happens, It's almost like you factor out the minus as like a GCF, okay? And then you can see why this turns out to be multiplication on the bottom. Okay, so let's move on to number 19. So number 19, you can see is similar to number 18 if we were to pull out that minus sign. So we're going to kind of go from there and say that this is going to be the natural log of x divided by, and then the product of x plus 1 and x minus 1. So x plus 1 times x minus 1. And we can simplify this a tad. We can FOIL or multiply these together using the distributive property, and we'll get x squared plus 1x minus 1x will be 0, and then so minus 1. For number 20, we have all kinds of stuff going on. So I'm going to actually take this a little slower than the last one. First, I'm going to distribute this 4 into both of these two logarithms. And so I'll get 4 natural log of x plus 4 natural log of x plus 5 minus 2 times the natural log of x minus 5. So after that, I'll apply that power property and rewrite all these coefficients as exponents. Oh, you know what? I can just type it. So to the 4th power, to the 4th power, and this one will be squared. Okay, so now I can use the product property here, and there are some implied grouping symbols here if you really want to put them in there. You can. You don't really need to, but it can help to clarify your argument if you want to throw those in there. But yeah, so let's wrap this up. So we got natural log of x to the 4th times x plus 5 to the 4th, and I'm not going to make you multiply that out. We can just go ahead and leave that there. All divided by x minus 5 squared. Okay, so yeah, we're going to get an 8th degree polynomial on top and a 2nd degree on the bottom. It's possible we could simplify this. I don't think there's really much we can do, so I'm going to leave it right there. There's really no point in trying to unfactor this or try to multiply this out. Okay, so there's number 20. Now we've got a challenge problem here. And this is a little bit more like what I would expect, not number 16. This one I think was just a typo. It's just kind of a bad problem. But what I wanted to say about that is that just because the logarithm spaces are different doesn't mean you cannot solve it. So watch how we could solve something like this. Or not solve, but simplify. We want to write this as a single logarithm. So let's try to rewrite it so that both bases are 4. So like log base 4 of x, you could just leave as is. And then we can rewrite this one using the change of base formula that we did with the beginning problems. We can write it as log base 4 of y divided by log base 4 of 16. So this is how we convert to whatever base we want. And this log base 4 of 16 is something we can evaluate, right? Since 4 squared is 16, then that means that whole thing is just 2, right? And from here, we can say, okay, well, one way we can rewrite this is if, oh, come on. Let me pull this up just a little bit. I didn't give myself very much room on here for this problem. So the way we're going to rewrite this is we're going to, instead of dividing by 2, I'm going to rewrite it so that we are actually multiplying by 1/2. And the reason why I'm doing that is so that I can use the power property. So you can kind of see how we're slowly getting there. So this I can rewrite as log base 4 of x plus log base 4 of y to the 1/2 power. Now, if you're raising something to the 1/2 power, that is equivalent to the square root. So if you want to write that as a square root, you may. Either way is fine, as far as I'm concerned. And so now we can use the product property. So we have log base 4 of x times y to the 1/2. And there you go. That would be your answer for that challenge problem. Okay, so it looks like we've just got a couple more problems here, and we are going to use the properties of logarithms to solve these. On number 21, notice that these two equations are equal to each other. So we can drop the log base 5s and just set the arguments equal to each other and get x plus 1 equals 6. Yeah, so we could subtract 1 from both sides and get x equals 5. And there's your solution to number 21. Now, you want to be careful. You want to make sure that this is a valid solution. You can't have any negative numbers inside the parentheses, so you just want to check and make sure you don't end up with that. 5 plus 1 is 6, so there's really no issue there. Number 22, same thing. We're going to drop the two logarithms, and we get x minus 3 equals 9. So adding 3 to both sides, we get x equals 12. For number 23 now, we don't have a logarithm on both sides. Nope. So we can't use this little trick that we did for 21 and 22. Instead, we're going to combine the logarithms and then rewrite as an exponential equation. So here, I'm going to combine these to get log base 2 of x times x plus 1 equals 1. Now, I can go ahead and just multiply these together. Okay, x times x is x squared. And x times 1 is just x. And so now I've got a logarithmic statement that I can sort of rewrite and try to isolate x here. So I'm going to rewrite it as an exponential equation. 2 to the power of 1 equals x squared plus x. And as we know, 2 to the first power is just 2. And then if I subtract 2 from either side, I get 0 equals x squared plus x minus 2. And this is something that I can factor. So we got a quadratic here. Oops. Okay, so I've got 0 equals x plus 2 times x minus 1. So algebraically, I do get two solutions here. I get negative 2 and I get positive 1. So I'm going to check and make sure that neither one of these makes my original statement invalid. So there's not like an extraneous solution here. So going back to the beginning, see if I plug in negative 2 here or even here, either one, I'm going to end up with a negative number inside the parentheses. So this solution is extraneous. We're going to get rid of the negative 2. And then we'll check 1. Put a 1 here, that's positive, no problem there. Put 1 here, that's 2, that's positive, no problem there. So yeah, so our solution here is just going to be 1. For number 24, same thing, except we'll use the quotient identity or property rather than the product one. So we got log base 3 of x divided by x plus 1 equals 2. From here, we can rewrite this using exponents. So 3 squared equals x over x plus 1. 3 squared here is just 9, okay? And then if I multiply x plus 1 on both sides, I'm going to get 9x plus 9 equals x. From here, I can subtract x from both sides can get 8x plus 9 equals 0. Subtract 9 from both sides, and I get 8x equals negative 9. And then divide both sides. So here I get negative 9/8, which if I go back to my original equation, that's not going to work. I can't have a negative number in here. So we end up here, unfortunately, with no solution. This is an extraneous solution, so there's really nothing. There's no number that I can plug in here that'll make it work, so there's no solution. For number 25, I do have logarithms on both sides, but I can't just drop everything up front. Instead, I'm going to have to combine, because you can only have like a single logarithm on both sides to make that work. So I've got natural log of x minus 1 times x plus 1. So I'll have to multiply all that out. Do that on the next step. Equals natural log of x plus 5. Now that I have a single logarithm on either side, I can drop both logarithms and just set the two arguments equal to each other. So I'm going to kind of do two steps in one here. I'm going to go ahead and multiply the x minus 1 times x plus 1. That'll be x squared minus 1. And I'm also going to drop the logarithm. So I got x plus 5 on the other side. I need this to be equal to 0 because it's quadratic to solve it. So we're going to have x squared minus x, and then if I subtract 5 from both sides, I'll get minus 6. So this is factorable, and it'll factor as x plus 2 times x minus 3. And so my solutions here, or at least my potential solutions here, are going to be negative 2 and 3. So going back and look, I'm checking to make sure negative 2 looks like it might cause some trouble, and it does. Okay, I get a negative argument here. We're not going to get any negative powers, so that one's going to be extraneous. Looks like I swapped colors, so it's okay. This one's going to be extraneous. And then if I plug in 3, that doesn't seem to cause any problems, so that is going to be my answer. Last problem here, number 26. I'm going to use the quotient property, and so I get log of 2x minus 21 all over x plus 12 equals log x. At this point, I can drop the both of the common logs, so I'll just have everything except for that. Let's get rid of the log over here and the log over here. From here, I want to multiply both sides by x plus 12 so that I get rid of this fraction. And so x times x plus 12 would be x squared plus 12x. All right, so what's next? We need to make this equal to 0, so I'm going to subtract 2x from both sides and add 21 to both sides. And so 12x minus 2x is going to be 10x. And if I add 21 to both sides, I get plus 21. I need to go ahead and factor this. So I get x plus 7 times x plus 3. So my solutions here, at least my potential solutions, are going to be negative 7 and negative 3. So let's see, are any of those going to cause issues? Oh, they're both going to cause issues. There's going to be another no solution. Well, that's unfortunate. Yeah, neither one of these are going to work, because look what we got over here, log x. So we can't have a negative x value. Both of these are bad. Gosh, you go through all that work to end up with no solution. That's kind of annoying. But, you know, sometimes that happens. All right, well, that's it for today. As always, if you guys have any questions, please reach out and I'll help you out. Otherwise, y'all have a great day, and I'll see you next time.